Hi. Today we're going to be talking about solving algebraic equations. Now in the past, we've mostly focused on dealing with algebraic expressions. What's an expression? Basically, a combination of numbers and variables that we have to simplify. For example, x minus 2, or 3 times y, which remember we write as 3y. We basically take the 3 and combine it with the y. Or 5z divided by 2. These are all expressions. But now we'll deal with equations. We're going to add on an equal sign and another number. If that seems like gobbledygook, don't worry. You've dealt with equations before, and you've solved equations before. If your teacher were to hand you an arithmetic worksheet and say 2 times 5 equals something, you'd say, all right, well, I have to fill in the blank. 2 times 5 is 10, so I'm going to write 10 here. Well, you have already solved equations. The only difference that we're doing with algebra is that instead of filling in the blank here, we're filling the blank when it comes to x, right? Let me give you an example. Say we have x minus 2 equals 7. In this case, this isn't a blank. We know that this is 7, but we want to solve for x. What does that mean? Basically, we want to find the number that is x, the number that represents this unknown quantity. Well, what does that mean? Well, in algebraic terms, we want to find this. X equals some number. So, how do we find that? We want to arrange this entire equation so that it looks something like this. X equals some number. Essentially, we want to have x all by itself on one side of the equation. How do we do that? Well, I notice if I add 2 to negative 2, I'm going to have 0. All right, so if I were to do x minus 2 plus 2, I'd just be left with x. X equals. This is what I want. But remember, whatever I do to one side, I have to do to the other side of the equation. Because otherwise, my equation will become unbalanced, and then I won't have an equation anymore. So, just as I added 2 to this side, I have to add 2 to this side. So, 7 plus 2, which turns out to be 9. Right? So I have x equals 9. If that seems confusing, don't worry. We're going to do another example. Say I have something like this. 2x minus 2 equals 4. And we want to solve for x. So we want to have one side of the equation that is x equals. Right? We want to get rid of all this other junk. We want to get rid of this negative 2 over here. We want to get rid of this coefficient of 2 here. We just want to have x. So how do we do that? Well, we always start by getting rid of the constants. Plus 2, minus 5. Anything that's added or subtracted, we want to get rid of because it's really easy to do. We just need to add or subtract the inverse, right? Negative 2. How can I get rid of negative 2? By adding 2. So I'm going to add 2. But remember, whatever I do to one side of the equation, I have to do to the other. So I'm going to add 2 to here. This is unchanged. So I have 2x, this cancels out, equals 4 plus 2, which is 6. Right? Now I have to get rid of this guy, because I just want to have x by itself. Now, how do I do that? Well, if you remember back to a previous video, we said that when we're multiplying a variable and a number, we smush them together. So we don't write 2 times x because that would be confusing, right? This is an x or a multiplication symbol. We're not quite sure. So we smush them together and you write 2x. So this is really 2 times x. Well, if I were to divide this by 2 then, I'd be left with just x, right? 2 times x divided by 2, that gets rid of the 2. Think about it a different way. 2 times 5 is 10. If I divide 10 by 2, I get 5. we're doing the same thing. Say we just have 2 times x divided by 2, and we're left with x. So, in either case, we're able to cancel out this 2. So we get x all by itself. That's great! But, before we go on and solve it, we have to do what we did at this side to the other side. So we have to divide 6 by 2. What's 6 divided by 2? That's 3. That means our final answer is 3. Now, let's keep this up. Let's not lose our momentum here. Let's do another problem. Say I have something like this. 4 times 2x minus 9 equals 20. Now I might say, oh, this parentheses. That looks very scary. Am I going to have to use the distributive property? Well, remember, let's simplify this. We want to get x all by itself. That's what we want to do every single time. Have x all by itself on one side of the equation. To do that, we're going to need to divide by 4 to get rid of these parentheses that are just clogging up the entire equation. And we have to do it to the other side too. So we've gotten rid of this cumbersome mess of parentheses. We're just left with 2x minus 9 equals 20 divided by 4, which is 5. All right, now we just got to get back in the groove. I want to get rid of all my constants, my adding and subtracting. So I'm going to get rid of this. How do I get rid of negative 9? By adding positive 9. That gets me 0, and that means I can forget about it, because 0 doesn't affect us. But remember, I do it to the other side too. So I have 2x equals 14. Now last step, we got to divide by 2 to just get x by itself. I do it on both sides too. So we end up getting x equals 7. And that is our final answer. This looks all well and good. Nice easy process, right? We didn't even have to use the distributive property. Well, not so fast. There are some cases where we'll need to use the distributive property and other properties that we've learned before when solving algebraic equations. For example, what if we took this original equation, instead of making it all nice and pretty and happy, we made it a bit more dirty and messy. We had 4 times 2x minus 9, right, so far so good, equals 4 plus 4x minus 6x. Oh no, we have x's on both sides of our equation. How are we supposed to do this? We can't solve for x by just getting x on one side. We have x on both. So far, we've been lucky enough that we've had x on a single side, and we're just trying to remove all the other nonsense stuff to just get x by itself. But we can't do this anymore. We have x on both sides of our equation. What are we going to do? Well, don't panic. The first thing we're going to do is simplify. See, we have 4x and negative 6x. They both have an x in them. They're common terms. They're like terms. That means we can combine them. 4x minus 6x is negative 2x. So we have 4 minus negative 2x over this mess here. And now I'm going to need to distribute. I'm going to need to use my distributive property. That means we're going to multiply this 4 by everything inside here. 4 times 2x, that's 8x. Bring my sign down. That's just minus sign. I don't touch that. 4 times 9, that's 36. So I have 8x minus 36 equals 4 minus 2x. Now, in order to eventually get x all by itself on one side, I'm going to need to put all my x's onto a single side. Now, it doesn't matter which side I choose, but in this case, I'm just going to choose the left-hand side. So I want all my x's on the left-hand side. How do I do that? Well, I want to get rid of the x's here. How do I do that? Well, I have a negative 2x. If I add 2x to that side, I'm going to get 0. So I'll have no x's on the right-hand side. Let's do that. But remember, whatever I do to one side, I have to do to the other. So I'm going to have to add 2x here. 8x plus 2x equals 10x. So I have 10x minus 36 equals 4. Now, At last, we're back in familiar territory. I want to get rid of this 36 here, so I'm just left with x's. So I'm going to add 36 to cancel that out. Have to do it both sides. I'm left with, I'm going to go up here. 10x equals 40. We're really close now, but we want to find x all by itself. We know 10x equals 40, but we still don't know what x itself equals. How do we find that? We divide by 10. That cancels out this. We got to do it on both sides. So we have x equals 4. That is our final answer. So, when solving algebraic equations, a few key things to keep in mind. Always, always, always simplify first. We notice we had common terms here, so we want to simplify them to make our life a lot easier. Next, know when to use your key properties. We saw we had parentheses here, and we were multiplying this algebraic expression by 4. That means we're going to need to use the distributive property. And finally, once you're left with a form that you can understand, get all your x's on one side, get rid of the numbers, the constants first, right? These 36, then get rid of your coefficients. And you get rid of your coefficients by dividing. That's all I have for this video. I hope this helped. I hope you have a great day.